Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all doing well. Dear student, this lecture is for grade 9, subject chemistry, chapter number 8, and today we will do the exercise of chapter number 8. This is my 31st lecture, and I am your lecturer, Mrs. Saira Jamal. Let us do the MCQs first. Question number 1, that is MCQs. MCQ number 1, encircle the correct option. Which of the following oxides is the most basic oxide? Like you can see that these basic oxides are actually magnesium, calcium, barium, and strontium. All these metals, they belongs to group number 2 of the periodic table. And if you see their sequence in the group, so the sequence is magnesium, after magnesium is calcium, then after calcium is strontium, then barium, okay. So you can see that the sequence of these elements in the periodic table in group number 2 is magnesium, calcium, strontium, and barium. And if you remember, I told you that the basic character increases down the group. Down the group, the basic character increases. So I can write basic character increases down the group. So as basic character increases down the group, it means that the barium oxide will be more, the oxide of barium will be more basic than the other oxide. So the correct option is B option. That is, the oxides of barium are most basic oxide than magnesium oxide, calcium oxide, and strontium oxide. And the reason I told you that as we are going from top to bottom along the group, the basic character of the oxides increases. MCQ number 2 is which of the following oxides is amphoteric oxide? So group number 1 sodium oxide, group number 2 magnesium oxide, and this is group number 6 sulfur dioxide. So these two are metallic in nature. Sulfur dioxide is acidic oxide. So the correct option is aluminum. Aluminum oxide, which is in group number 3 of the periodic table, is amphoteric oxide, that it can behave like an acid as well as a base. MCQ number 3 is which of the following element is most metallic? So like we have aluminum, magnesium, then sodium and lithium. The sequence are that lithium is in group number 1, and after lithium is sodium in group number 1. Then magnesium is in group number 2 with the same period of sodium. So we can write it magnesium in group number 2, and then aluminum in group number 3 in the same period. So if you remember, dear students, I told you that when we are going from top to bottom along the group, so metallic character increases, but we will go from left to right along the period, then metallic character decreases. So which one will be most metallic in nature? Lithium is, like you can say, less metallic than sodium, and sodium is more metallic than magnesium and aluminum. So correct option is sodium. Sodium is more basic than lithium, aluminum, and magnesium. MCQ number 4, valence shell electronic configuration of alkaline earth metals is alkaline earth metals. I told you are the group number 2A elements, and you know that all the elements in the periodic table, they are arranged on the basis of their valence shell electronic configuration in the periodic table. So it is understood that all the group number 2A elements or alkaline earth metals, they are also called S block element because their valence electron lies in the S subshell. So their valence shell electronic configuration become NS2. NS2 means like the subshell will be S subshell because they are S block element and having 2 electrons in that shell. So that's why they're called S block element and group number 2 elements. Number 5, which of the following metals is not noble metal? Now you remember, if you remember, I told you that noble metals are those metals which are highly stable, least reactive or inert. They does not react even with strong acids and strong bases, except aqua regia, which is a special type of solution used for the gold and platinum. So, like which of the following is not noble metal? Au is a symbol of gold. It is noble metal. Copper is a noble metal. Yes, silver is noble metal because we are making jewelries and coins of all these metals. So the option is mercury. Mercury is not that much inert or not stable. So mercury is not a noble metal. Then number 6, which of the following elements is the least non-metallic? And least non-metallic, if we see the sequence of all these elements, so the first one will be silicon because silicon is present in group number 4. After silicon is group number 5, that is phosphorus. Then group number 6 is sulfur, and group number 7 is chlorine. Group number 7 is chlorine. And if you remember, I told you when we will move from left to right along the period, the non-metallic character increases. The non-metallic character increases while metallic character decreases. So as the non-metallic character increases, when we move from left to right, it means chlorine will be the most non-metallic in nature, then and silicon will be most metallic. Silicon metallic and chlorine most non-metallic. But they're asking about least non-metallic. So chlorine is most non-metallic, then sulfur is more metallic than phosphorus, and phosphorus is more non-metallic than silicon. So the option is which one is most least non-metallic or more metallic, that is silicon, which is option number A. Option A is the correct option, that silicon is the most least non-metallic and most metallic in this case. MCQ number 7, oxidizing power of dash is the highest. Which one of the following has strong oxidizing power? And the elements which are mentioned, the molecules actually are mentioned: iodine, bromine, chlorine, and fluorine. And if you remember, I told you about their sequence in periodic table, that fluorine in group number 7 comes first, then after fluorine is chlorine, then after chlorine is bromine, and then iodine, And I told you that all of these, they exist in dimolecular or in the diatomic form, or you can say in molecular form. They exist in molecular form, I2F2 Cl2. They are called molecular form. And if you remember, I told you that their oxidizing power decreases down the group. Oxidizing power decreasing down the group. So the most or strongest oxidizing agent will be fluorine. Fluorine will be the strongest oxidizing agent, and iodine will be the weakest oxidizing agent. So they say oxidizing power of dash is the highest. So as I told you that which element the oxidizing power is highest? Yes, fluorine. Oxidizing power of fluorine is the highest. Then next one, chlorine cannot oxidize dash ion. Now one more thing is that keep this in your mind that fluorine can oxidizes all the elements which are present under fluorine in the other periods. And the top element can oxidize all the down elements or the downward molecules, but the down molecules cannot oxidize the upper molecule which has strong oxidizing power. The least oxidizing power element or molecule they cannot oxidize is the strong oxidizing power molecule. So fluorine can oxidize chlorine, bromine, and iodine, but iodine cannot oxidize bromine, chlorine, or fluorine. So it means the lower element or lower molecule cannot oxidize the molecule or element which are present above them. So chlorine cannot oxidize this. Chlorine is at the second number and fluorine is above fluorine. So chlorine cannot oxidize this fluorine. Although the lower molecule like bromine and iodine, chlorine can oxidize them, but chlorine cannot oxidize this fluorine because fluorine has stronger oxidizing agent than fluorine. So the weak oxidizing agent cannot oxidize the strong oxidizing agent. So the correct option in this case is fluoride ion. MCQ number 9, sodium is more reactive than lithium but less reactive than. Again, this is about the group number, uh, sodium is in group number 1, and if we mention their sequence in the periodic table, then you can see that we have sodium is present in group number 1. Then we have magnesium. Magnesium is present in group number 2, and aluminum in group number 3. So we have group number 1 is sodium. Then group number 2 is magnesium. Group number 3 is aluminum. And that is rubidium. Rubidium is present in group number 1. That is sodium, potassium, and then rubidium. After potassium is rubidium. Sodium, then potassium. Here potassium is also, but potassium is not mentioned in this option. Sodium, potassium, and then rubidium. So they ask sodium is more reactive than lithium because lithium is present above sodium in group number 1. And I told you reactivity increases down the group. Reactivity of metal increases down the group. It means rubidium is more reactive than potassium, and potassium is more reactive than sodium. Sodium is then more reactive than lithium. So they say sodium is more reactive than lithium, but less reactive, and then less reactive than potassium or less reactive than rubidium. But in these option, potassium is not given, rubidium is given, so sodium is less reactive than rubidium. Why not magnesium and aluminum? Because the reactivity of metal from left to right along the pair decreases. I told you this. Reactivity down the group increases. Down the group, the reactivity of metal increases, while from left to right, the reactivity of metals decreases. So that's why we will consider top to bottom. So sodium is more reactive than lithium and less reactive than rubidium. MCQ number 10, which of the following is the strongest acid? Again, if you remember, I told you hydrofluoric acid, then chloric, then bromic, and then iodic acid. So acidic character decreases down, the acidic character increases down the group. So the last one, hydroiodic acid will be the strongest acid, and hydrofluoric will be the weakest acid, because the acidic character increases down the group. So this was all about the MCQs. 10 MCQs were there. Now coming towards the short question answers, that is question number 2. The first short question is, in a group the reactivity of metals with oxygen increases. Give example. As I told you that when we move from top to bottom along the group, the reactivity of metals increases. That is, if its reactivity is with oxygen or with any other element, but reactivity increases from top to bottom along the group. And we have to give evidence of that, that yes or no, the reactivity increases or not. So the answer is yes. In a group, the reactivity of metals with oxygen increases. For instance, alkali metals on exposure to air, means when they react with air, show an increase in affinity for oxygen as we move down the group. Affinity for oxygen increases, like they react with more oxygen, which show that they have more affinity or more attraction toward the oxygen. So lithium form normal oxide. Lithium is present in group number 1 and the first element. So after hydrogen, hydrogen is a non-matter. So lithium react with oxygen and will form normal oxide. And if you remember, I told you that in normal oxide, the oxidation state of oxygen is -2. So in this case, the oxidation state of oxygen is -2. So these type of oxides are called normal oxide. Which type of oxide? Normal oxide. Sodium react with oxygen to form peroxide. Now in this case, you can see that -2 is for two oxygen atoms, but for one oxygen atom, but here we have two oxygen atoms. So we will divide -2 by 2. It will give us the answer -1. It means that in this case, in peroxide, the oxidation state of oxygen is -1. So these type of oxides are called peroxides. These type of oxides are called peroxide. And then the third element, that is a reaction of potassium with oxygen, it will give us the superoxide, because if you see, we have the oxidation state of potassium, that is +1, because we have only one potassium in this case. So the oxidation state of potassium is +1, and that of oxygen become, if one potassium, because it is present in group number 1, its oxidation state is +1. So definitely we need -1 for one potassium, but we have two potassium in this case, so we will divide it by 2. So means one oxygen is -half. -1 is for two oxygen atom, and -half is for one oxygen atom. So those type of oxides in which the oxidation state of oxygen is -half, those oxides are called superoxide. So you can see that the affinity, one potassium is making bond with two oxygen atoms. It means the affinity of this metal with oxygen increases. That's why one potassium make bond with two oxygen atoms. So potassium, rubidium, and cesium form a superoxide. While the reverse is that as we move from left to right along the period, the reactivity of metal with oxygen decreases. From top to bottom, reactivity with oxygen increases, and from left to right, reactivity of metal with oxygen decreases. Question number 2. Which element is more metallic, magnesium or aluminum? Magnesium is present in group number 2 and aluminum in 3, although both are present in the same period, period number 3. Magnesium and aluminum are the members of period 3. If we apply the trend that when we are moving from left to right along the period, what happened? I told you the metallic character decreases, so the electropositive character decreases. So this means that as magnesium is present in group number 2 and aluminum in 3, so magnesium will be more metallic than aluminum. Question number 3. Question number 3 is, what is the importance of magnesium? So magnesium, you know, is relatively low density, means it is lighter in weight and is used in making lightweight alloy with aluminum. Aluminum also is lighter in weight. So these two metals are lighter in weight. So they are combined together to form an alloy, and that alloy is used for making frames of automobiles, aircraft, and spaceship, cameras, etc. Another application is magnesium burns brilliantly. So that's due to this property, it is used in photo flash guns, and magnesium hydroxide, which is called milk of magnesia, is commonly used as an anti-acid. So to neutralize the acidity in stomach, we use the suspension of magnesium hydroxide. Question number 4 is, arrange the following in order of increasing acidic strength. I told you all these acids are from group number 7. And if you remember, I told you that when we are moving from top to bottom along the group, so what will happen? The first one is fluorine. So the fluorine react with oxygen and will form acids. So that is called hydrofluoric acid. They are also called hydrogen. They are also called halides. Hydrofluoric acid. Then we have hydrofluoric acid. Then hydrobromic acid. And the last one is hydroiodic. So the acidic strength, as I told you, when we are going from top to bottom, the acidic strength increases. Acidic strength increases. So the strong acid is that one which can easily donate a proton, or which can easily give a proton or hydrogen ion. So the large size of hydroiodic acid help in the easiest removal of proton or hydrogen, make it strongest acid. So the hydrogen halide, when dissolved in water, they form hydrohalic acid. For example, hydrochloric acid, hydrofluoric acid, etc. Except hydrofluoric acid, other hydrohalic are strong acid, and the acidic strength increases in the following order. I told you hydroiodic is the strongest acid, then hydrobromic, hydrochloric, and the weakest is hydrofluoric acid. Hydrofluoric acid will be the weakest, and hydroiodic acid is the strong acid. I told you the reason, the large size. Then question number 5, can fluorine oxidizes all the halide ions to free halogen? As you remember, I told you that the oxidizing power decreases down the group in halogen family. So fluorine is the highest or strongest oxidizing agent, or it has strongest oxidizing power than that of iodine. So due to the relative strength as oxidizing agent, it is possible for fluorine to oxidize the ions which are present next to it in the group. So this means that fluorine can oxidizes all the halide ions to free halogen, and we can understand this property of fluorine by the help of these examples. You can see fluorine can displace chlorine and can form potassium fluoride, and fluorine can also displace bromine and can form potassium fluoride, and bromine in free form, chlorine in free form, same iodine in free form and can form sodium fluoride. So in all the cases, we can see that fluorine can displaces all these ions which are present next to them in the next to it in the periodic table. And as I told you that this is called the oxidizing power of fluorine. Why is it called the oxidizing power of fluorine? Because you can see that the oxidizing power of the oxidation state of chlorine in this case is -1, and it is converted into zero oxidation state. So you know that zero is bigger than -1, and increase in oxidation state is called oxidation. Increase in oxidation state is called oxidation. It means that the uh, it means that the fluorine itself is reduced from zero, it is converted into -1 oxidation state. So fluorine is reduced, fluorine by itself is reduced because it undergoes from 0 to -1 oxidation state. But the chlorine is oxidizes because from -1 it is converted into the zero oxidation state. So zero is bigger than the -1. So fluorine itself is reduced and hence will act as an oxidizing agent, and chlorine is oxidizes in this case and can act as a reducing agent. Another example is fluorine with the bromine, the same thing. Bromide ion is in -1 oxidation state, but over here it is in the zero oxidation state. And fluorine from zero is converted into -1. Same thing. Fluorine undergoes oxidation state from 0 to -1, that is decrease in oxidation state. So decrease in oxidation state means that a reduction of fluorine takes place. We will call it a reduction of fluorine molecule will takes place, and it can be used as an oxidizing agent. We can use this fluorine as a oxidizing agent. And in this case again fluorine from 0 to -1 and iodine from -1 to 0. So you can see that fluorine can displace all these ions. Fluorine can displace chloride ion, fluorine can displace bromide ion, fluorine can displace iodide ion. The reason is due to its strong oxidizing power. It can displace all the other elements which are present next to fluorine in its group. Now, short question answers are completed. Coming towards the long question answer, question number 3. Arrange the following oxides in order of decreasing basic character. Beryllium, calcium, magnesium, strontium, all these belongs to group number 2A of the periodic table, and the sequence is same. Beryllium, calcium, magnesium, strontium. And if you remember, I told you that the basic character increases when we move from top to bottom. So the strongest basic character will be of strontium, then magnesium, then calcium, and then the weakest or the lowest basic character will be of beryllium oxide. But as they ask for decreasing basic character, that's why we will start from the strongest basic character to the weakest basic character. So sodium oxide is most basic, then calcium oxide, magnesium, and the least basic is beryllium oxide. So we will write it in this manner. Next question is question number 4. Rank each set of elements in order of increasing metallic character. We have aluminum, sodium, magnesium. A part, aluminum, sodium, and magnesium all lies in period number 3 in same period. And as you know that when we are moving from left to right, electropositive character decreases. Therefore, decreasing metallic character is given by we will decreasing metallic character is the sodium is more metallic than magnesium, and magnesium is more metallic than aluminum. So as it is on the basis of increasing metallic character, so the symbol must be in this form. Sodium is more metallic than magnesium, and magnesium is more metallic than aluminum. So this is the correct sequence. B is sodium, lithium, and potassium. So they are present in group number 1, and again we have to arrange them on the basis of increasing metallic character. Increasing metallic character from lowest toward the weakest, increasing metals. Over here again we have to write first here aluminum, because we are going from least metallic to more metallic. Then after aluminum is magnesium, and then the strongest is sodium. Sodium is more metallic. So as we are going from least to strongest metallic character, so this is the correct sequence. Same is over here, lithium, sodium, potassium, and they belong to the same group. And the metallic character increases as we go down the group. So potassium is more metallic than sodium, and sodium in turn is more metallic than lithium. This is correct. This was about the question number 4. The other question, inshallah, we will continue in our next lecture. Think tank and some questions are left. Inshallah, we will continue it in our next lecture. Till then, take care. Allah.